This is AP Environmental Science, Chapter 1, Environmental Problems, Their Causes, and Sustainability. This lecture will cover Section 2, How are our ecological footprints affecting the Earth? For this section, there is one key concept. As our ecological footprints grow, we are depleting and degrading more of the Earth's natural capital. We are living unsustainably. The Earth is a beautiful, largely blue and white island of water, land, and life that moves around the sun at about 107,000 kilometers per hour, which is the same thing as 67,000 miles per hour. The life on this planet has been sustained for billions of years by solar energy, chemical cycling, and biodiversity, which are the scientific principles of sustainability. However, a large and growing body of scientific evidence indicates that the human species, a relative newcomer on the planet, is violating these sustainability principles. In fact, we are living unsustainably by wasting, depleting, and degrading the Earth's natural capital at an accelerating rate, which is a process known as environmental degradation. Scientists also refer to this as natural capital degradation. In many parts of the world, renewable forests are shrinking, deserts are expanding, topsoil is eroding, and suburbs are replacing croplands. In addition, the lower atmosphere is warming, floating ice and glaciers are melting at unexpected rates, sea levels are rising, ocean acidity is increasing, and floods, droughts, severe weather, and forest fires are more frequent in some areas. In a number of regions, rivers are running dry, harvests of many species of fish are dropping sharply, and coral reefs are dying. Species are becoming extinct at least 100 times faster than in pre-human times, and extinction rates are projected to increase by at least another 100-fold during this century. In 2005, the UN released its Millennium Ecosystem Assessment, a 4-year study by 1,360 experts from 95 countries. According to this study, human activities have degraded or overused about 60% of the Earth's natural or ecosystem services, mostly since 1950. The report's summary stated that human activity is putting such a strain on the natural functions of Earth that the ability of the planet's ecosystems to sustain future generations can no longer be taken for granted. The report also concluded that we have scientific, economic, and political solutions to these problems that we could implement within the next few decades in order to make the transition to a more sustainable future within your lifetime, as well as you will learn from this course. Pollution comes from a number of sources. A major environmental problem is pollution, which is contamination of the environment by a chemical or other agent such as noise or heat to a level that is harmful to the health, survival, or activities of humans or other organisms. Polluting substances, or pollutants, can enter the environment naturally, such as from volcanic eruptions or through human activities, such as burning of coal or gasoline, and the dumping of chemicals into rivers, lakes, and oceans. At a high enough concentration in the air, in water, or in our bodies, almost any chemical can cause harm and be classified as a pollutant. The pollutants we produce come from two types of sources. Point sources are single, identifiable sources. Examples are smokestacks of burning coal power or industrial plants, the drain pipe on a factory, or the exhaust pipe of an automobile. Non-point sources are dispersed and often difficult to identify. Examples are pesticides blown from the land into the air and the runoff of fertilizers, pesticides, and trash from the land into streams and lakes. It's much easier and cheaper to identify and control or prevent pollution from point sources than from widely dispersed non-point sources. We have tried to deal with pollution in two very different ways. One approach is pollution cleanup, which involves cleaning up or diluting pollutants after we have produced them. For example, we can dilute and reduce the local effects of air pollutants from smokestacks by releasing them high into the atmosphere, where winds can carry them to downwind areas. However, while tall smokestacks can reduce local air pollution, they can increase air pollution in downwind areas. The other approach is pollution prevention. Efforts focus on greatly reducing or eliminating the production of pollutants. For example, we can enact pollution control laws that ban or set low levels for the emissions of various pollutants into the atmosphere or into the bodies of water. Many environmental scientists say that pollution prevention is a key to a more sustainable future because it works better and in the long run is cheaper than cleanup. The tragedy of the commons: degrading commonly shared renewable resources. Some renewable resources, known as open access renewable resources, can be used by almost anyone. Examples are the atmosphere, the open ocean, and its fishes. Other examples of less open but often shared resources are grasslands and forests. Many of these commonly held resources have been environmentally degraded. In 1968, biologist Garrett Hardin called such degradation the tragedy of the commons. Degradation of a shared or open access resource occurs because each user of the resource reasons, if I do not use this resource, someone else will. The little bit that I use or pollute is not enough to matter. And anyway, it's a renewable resource. When the number of users is small, this logic works. Eventually, the cumulative effect of many people trying to exploit and share resources can degrade it and eventually exhaust or ruin it, and then no one can benefit from it. This is a tragedy. There are two major ways to deal with this difficult problem. One is to use a shared or open access renewable resource at a rate well below its estimated sustainable yield by using less of the resource, regulating access to the resource, or doing both. For example, governments can establish laws and regulations limiting the annual harvest of various types of ocean fishes, or regulating the amount of pollutants that we add to the atmosphere or the oceans. The other way is to convert shared renewable resources to private ownership. The reasoning is that if you own something, you're more likely to protect your investment. However, history shows that shared renewable resources such as forests and soils can be quickly degraded once they are privately owned. Also, this approach is not practical for open access resources such as the atmosphere, the oceans, and our global life support system, which cannot be divided up and sold as private property. Ecological footprints: our environmental impacts. Many poor people in less developed countries struggle to survive. Their individual use of resources and the resulting environmental impact is low and is devoted mostly to meeting their basic needs and living in makeshift housing. However, a large number of such people in a given area can have a large total environmental impact. By contrast, Many individuals in more developed nations enjoy affluence or wealth, which allows them to consume large amounts of resources far beyond their basic needs and live in large homes filled with possessions. Their environmental impact is more of a product of their rates of resource use per person. When people use renewable resources, it can result in natural capital degradation, pollution, and waste. We think of this as harmful environmental impacts, and this is called ecological footprints. The amount of land and water needed to supply a person or an area with renewable resources, such as food and water, and that are needed to absorb and recycle the waste and pollution products by such resource use. The developers of this tool for measuring environmental impacts chose to focus on renewable resources, although the use of non-renewable resources also contributes to our ecological footprints. The per capita ecological footprint is the average ecological footprint of an individual in a given country or area. We can use various simple online tools to estimate our ecological footprints. Ecological footprints and per capita ecological footprints can be selected for various countries. If the total ecological footprint for a city, a country, or the world is larger than its biological capacity to replenish its renewable resources and absorb the resulting waste and pollution, it is said to have an ecological deficient. In other words, its people are living unsustainably by depleting their natural capital instead of living off of the renewable resources and supply of resources provided by such a capital. Globally, we are running up a huge ecological deficient. Ecological footprint data and models, though imperfect, provide useful, rough estimates of our individual, national, and global environmental impacts. We can use existing and emerging technologies and economic tools to reduce the size of our ecological footprints over the next few decades to the point where we only need one Earth to support the human population. We will discuss these ways to make this shift throughout the course. IPAT is another environmental impact model. In the early 1970s, Paul Ehrlich and John Holdren developed a simple model showing how population size, affluence, or resource consumption per person, and the beneficial and harmful environmental effects of technologies help to determine the environmental impact of human activities. This provides another rough estimate of how humanity is degrading the natural capital it depends on. We can summarize this model by simple equations. For example, impact equals population times affluence times technology. I equals P times A times T. Therefore, this is referred to as IPAT or IPAT. While the ecological footprint model emphasizes the use of renewable resources, this model includes the per capita use of both renewable and non-renewable resources. Some forms of technology, such as polluting factories, gas-guzzling motor vehicles, and coal-burning power plants, increase environmental impact by raising the harmful T factor. However, other technologies reduce environmental impact by decreasing the T factor. Examples are pollution control and prevention technologies, fuel-efficient cars, and wind turbines and solar cells that generate electricity with a low environmental impact. In most less developed countries, the key factor, total environmental impact, is usually population size, as a growing number of poor people struggle to stay alive. For example, while each individual in a rural village needs only a small amount of wood for heating and cooking, the total population of the village can eventually clear most of all of the trees in the nearby area for firewood. In more developed countries, the key factor in overall environmental impact is affluence, which can result in high rates of per capita resource use, pollution, and resource depletion. Affluence is also a key factor in less developed countries whose economic populations are growing. Cultural changes can grow or shrink our ecological footprints. Until about 10,000 to 12,000 years ago, we were mostly hunter-gatherers who obtained food by hunting wild animals or scavenging their remains, and gathering wild plants. Early hunter-gatherers lived in small groups, consumed few resources, had few possessions, and moved as needed to find enough food for their survival. Since then, 3 major culture changes have occurred. First was the agricultural revolution, which began 10,000 to 12,000 years ago, when humans learned how to grow and breed plants and animals for food, clothing, and other purposes. Second was the industrial medical revolution, which began about 275 years ago, when people invented machines for the large-scale production of goods in factories. This involved learning how to get energy from fossil fuels, such as coal and oil, and how to grow large quantities of food in an efficient manner. It also included medical advances that have allowed a growing number of people to live longer and healthier lives. Finally, the information globalization revolution began about 50 years ago, when we developed new technologies for gaining rapid access to all kinds of information and resources on a global scale. Each of these 3 cultural changes gave us more energy and new technologies with which to alter and control more of the planet's resources to meet our basic needs and increasing wants. They also allowed expansion of human population, mostly because of larger food supplies and longer lifespans. In addition, they each resulted in greater resource use, pollution, and environmental degradation, as they allowed us to dominate the planet and expand our ecological footprints. On the other hand, some technological leaps have enabled us to begin shrinking our ecological footprints by reducing our use of energy and matter resources and our production of waste and pollution. For example, use of energy-efficient compact fluorescent and LED light bulbs and energy-efficient cars and buildings is on the rise. Many environmental scientists and other analysts see such developments as evidence of an emerging 4th major cultural change in the form of sustainability revolution, in which we could learn to live more sustainably with smaller ecological footprints during this century. A key factor in making this transition involves asking ourselves, how much stuff do we really need in order to live healthful, comfortably, and happy lives? This concludes this section of Chapter 1 for AP Environmental Science. Feel free to review or repeat this lecture or any other of the APES lectures through the provided platform.